On July 1, 2025, astronomers discovered something extraordinary racing through our solar system. A massive interstellar object designated 3I/Atlas that dwarfs all previous visitors from beyond our cosmic neighborhood. This colossal traveler, potentially up to 12 kilometers wide, is moving at over 150,000 miles per hour on a trajectory that confirms its origin from another star system. Unlike the mysterious Oumuamua or the smaller comet Borisov, 3I/Atlas represents our largest confirmed interstellar visitor, offering unprecedented opportunities to study material from distant worlds before it vanishes forever into the cosmic void. The historic discovery. What started as a routine night of sky surveillance on July 1, 2025, became one of the most significant astronomical discoveries of the decade. The Atlas Survey Telescope in Rio Hurtado, Chile, operated by the University of Hawaii as part of NASA's Planetary Defense Network, detected an unusual moving object approximately 670 million kilometers from the Sun. Initially catalogued as A11PI3Z, this faint dot immediately caught astronomers' attention due to its peculiar trajectory and unexpected brightness. The Asteroid Terrestrial Impact Last Alert System, known as ATLAS, consists of 4 telescopes strategically positioned across the globe. 2 in Hawaii, 1 in Chile, and 1 in South Africa. These automated sentinels continuously scan the night sky, photographing the same regions multiple times to detect moving objects that might pose threats to Earth. However, what they discovered on that July night was something far more extraordinary than a potentially hazardous asteroid. Confirming interstellar origins. The confirmation that 3I/Atlas originated from beyond our solar system required careful analysis of its orbital mechanics and trajectory. Unlike objects native to our cosmic neighborhood, which follow predictable elliptical paths around the Sun, interstellar objects travel on hyperbolic trajectories, essentially one-way tickets through our solar system. Dr. Paul Chodas, director of NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory, explained that the object's velocity and trajectory definitively prove its interstellar nature. When astronomers traced its path backward through space, they found it approaching from the general direction of the galactic center, though pinpointing its exact stellar origin remains impossible due to the vast distances and timescales involved. The object's designation as 3I/Atlas reflects its historic significance. The 3I indicates it's the third confirmed interstellar object ever discovered, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. The Atlas portion honors the survey system that first detected it, while its formal comet designation C/2025N1 indicates it was the first non-periodic comet discovered in the first half of July 2025. What makes this discovery particularly remarkable is the object's speed relative to the Sun, approximately 60 kilometers per second or about 134,000 miles per hour. This velocity is far too high for any object gravitationally bound to our solar system, providing conclusive evidence of its interstellar journey. Unprecedented size and characteristics. The sheer scale of 3I/Atlas sets it apart from all previous interstellar visitors. Current estimates suggest the object measures between 5 and 15 kilometers in diameter, making it potentially dozens of times larger than Oumuamua, which was only about 400 meters long. If confirmed at the upper end of these estimates, 3I/Atlas would be the largest interstellar object ever observed. Dr. Daryl Seligman, an astrophysicist at Michigan State University, who has been studying the object since its discovery, describes 3I/Atlas as shockingly bright despite its enormous distance from Earth. This brightness could indicate either exceptional size or an unusually reflective surface composition. The object's luminosity allows telescopes to observe it clearly even though it remains much farther from Earth than Oumuamua was when discovered. Early spectroscopic observations reveal that 3I/Atlas exhibits a reddish hue, similar to objects in the outer regions of our solar system. This coloration suggests the presence of organic compounds and complex hydrocarbons that have been altered by billions of years of cosmic radiation exposure. Perhaps most intriguingly, 3I/Atlas shows clear signs of cometary activity, including a faint coma, a hazy envelope of gas and dust surrounding the nucleus. This activity indicates the presence of volatile materials like water ice, carbon dioxide, and other compounds that sublimate when heated by solar radiation. Comparing the interstellar visitors. The discovery of 3I Atlas gives astronomers their third data point for understanding interstellar objects, and honestly, it reveals some fascinating diversity among these cosmic wanderers. Each visitor has exhibited unique characteristics that, well, really challenge our expectations about objects from beyond our solar system. Oumuamua, discovered back in October of 2017, is still the most enigmatic of the three. Its extremely elongated shape, lack of visible cometary activity, and that mysterious non-gravitational acceleration, these all sparked intense debate about what it really is. Comet 2Y Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, turned out to be more conventional in its behavior. This object clearly showed typical cometary characteristics, including a visible tail and a composition similar to comets in our own outer solar system. 3I Atlas, though, seems to bridge the gap between its predecessors while introducing a whole new set of mysteries. Like Borisov, it shows cometary activity, but its enormous size and those unusual brightness patterns definitely set it apart. Dr. Mark Norris from the University of Central Lancashire notes that 3I Atlas doesn't look like either of them, which is crazy and exciting. The rapid succession of these discoveries, 3 interstellar objects in less than a decade after centuries of seeing none, suggests, such visitors may be far more common than we ever thought. Advanced Observational Campaign. The astronomical community has really mobilized an unprecedented international effort to study 3Y Atlas before it disappears into the depths of space. Unlike Oumuamua, which was discovered as it was already leaving the solar system, 3I Atlas was detected early enough to allow extended observation campaigns using the world's most powerful telescopes. The James Webb Space Telescope, with its exceptional infrared sensitivity and massive 6.5-meter mirror, is perfectly positioned to analyze the object's composition and thermal properties. Webb's instruments can detect specific molecular signatures in the comet's coma and tail, potentially revealing the presence of water vapor, carbon monoxide, methane, and other volatiles that could provide clues about its origin. The Hubble Space Telescope continues to monitor 3I Atlas using its ultraviolet and visible light capabilities, complementing Webb's infrared observations. Together, these space-based observatories provide a comprehensive view across multiple wavelengths of light, revealing details impossible to obtain from ground-based telescopes alone. Ground-based observatories worldwide have also joined the effort. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and numerous other facilities are tracking the object's brightness variations, rotation, and spectroscopic properties. Radio telescopes, including the Very Large Array in New Mexico, are monitoring for any unusual emissions that might indicate unexpected activity or composition. This coordinated global effort, honestly, represents the most comprehensive study of an interstellar object ever attempted, taking advantage of technological capabilities that just weren't available during previous encounters. Ancient origins and cosmic age. Recent research suggests that 3I Atlas may be one of the oldest objects ever observed, potentially predating our solar system by billions of years. Dr. Jesse Hopkins and his colleagues at the University of Oxford have developed models indicating that this interstellar visitor likely formed around an ancient metal-poor star in the galaxy's thick disk, a population of stars that formed when the Milky Way was much younger. Professor Chris Lintott, co-author of the Oxford study and presenter of BBC's The Sky at Night, explains that there's approximately a 2/3 chance this comet is older than our 4.6 billion-year-old solar system. If confirmed, 3I Atlas would represent a pristine sample of materials from the early galaxy, preserved in the deep freeze of interstellar space for eons. The object's ancient origins could explain its unusual characteristics. Unlike comets in our solar system, which have been repeatedly heated during passages near the Sun, 3I Atlas may be experiencing its first encounter with stellar radiation in billions of years. This pristine nature could account for its unexpected brightness and activity patterns. Dr. Michelle Bannister from the University of Canterbury notes that the gases released as 3I Atlas is heated by the Sun will test theoretical models about ancient comet composition. This temporal perspective transforms 3I Atlas from merely an interstellar visitor into a potential time capsule from the galaxy's youth. Trajectory and future encounters. So, 3I/Atlas is currently following a precisely calculated path through our solar system that will bring it to perihelion, its closest approach to the Sun, around October 30th, 2025. At this point, it will be approximately 206 million kilometers from the Sun, just inside Mars's orbit, but still at a safe distance that poses no threat to Earth. The object's trajectory offers both opportunities and challenges for observation. During its closest solar approach, 3I/Atlas will be positioned on the opposite side of the Sun from Earth, limiting direct observation during its most active period. Dr. Astor Taylor, a graduate student in astrophysics at the University of Michigan, explains that despite the object's incredible speed, astronomers will have several months to study it. The comet will remain visible to large telescopes until early 2026, after which it will fade into the darkness of space, never to return. On October 3, 2025, 3I/Atlas will make its closest approach to Mars, providing an opportunity to measure how planetary gravity might subtly alter its trajectory. The object's outbound journey will take it beyond Jupiter's orbit by mid-2026, beyond Saturn by 2027, and eventually beyond the influence of our solar system entirely, resuming its eternal voyage through the galaxy. Scientific implications and astrobiology. The discovery and study of 3I/Atlas carries, honestly, some pretty profound implications for our understanding of planetary system formation, the distribution of organic materials throughout the galaxy, and potentially the origins of life itself. As the largest confirmed interstellar object, it offers an unprecedented opportunity to analyze material from another stellar system in detail. If spectroscopic analysis reveals complex organic compounds within 3I/Atlas, it would support theories that interstellar objects serve as vehicles for distributing the building blocks of life across the galaxy. This concept, known as panspermia, suggests that life's ingredients, or even life itself, might travel between star systems aboard comets and asteroids. The object's ancient age adds another dimension to its astrobiological significance. Materials preserved in 3I/Atlas for billions of years could contain information about the early galactic environment when the first generation of planets was forming. Dr. Rosemary Dorsey from the University of Helsinki emphasizes that studying 3I/Atlas provides insights into the role that ancient interstellar comets play in seeding star and planet formation across the galaxy. The object's composition and behavior could reveal whether the chemical ingredients necessary for life are common throughout the cosmos. The discovery also informs models of planetary system evolution, suggesting that the ejection of material into interstellar space is a common process that connects distant stellar systems through the exchange of matter and potentially biological information. Future detection and exploration. The discovery of 3I/Atlas comes at a pivotal moment in astronomy, as new survey telescopes prepare to, really revolutionize our ability to detect interstellar objects. The Vera C. Rubin Observatory, scheduled to begin operations soon, will photograph the entire visible sky every few nights, creating a comprehensive movie of the cosmos that should dramatically increase the rate of interstellar object discoveries. Predictions suggest that Rubin Observatory might detect between 5 and 50 interstellar objects during its 10-year survey, with some potentially as large as 3I/Atlas. The discovery also highlights the potential for rapid response missions to intercept future interstellar objects. While 3I/Atlas was detected too late for any spacecraft to reach it, several space agencies are developing concepts for high-speed interceptor missions that could be launched on short notice when the next visitor is discovered. The European Space Agency has proposed the Comet interceptor mission, designed to study a pristine comet or potentially an interstellar object. NASA and other agencies are exploring similar concepts that could provide direct sampling and analysis capabilities, opening entirely new frontiers in space exploration. These future missions could answer fundamental questions about interstellar objects that remote observation cannot address, including their internal structure, precise composition, and the processes that ejected them from their home systems billions of years ago. A new era of cosmic discovery. The arrival of 3I/Atlas represents more than just another astronomical discovery. It marks humanity's entry into a new era of cosmic exploration where we can study material from distant star systems within our own solar system. Each interstellar visitor provides a unique window into the processes shaping planetary systems throughout the galaxy. As 3I/Atlas continues its journey through our cosmic neighborhood, it carries with it secrets from an ancient star system that may have died billions of years ago. The data collected during its brief visit will be analyzed for years to come, potentially reshaping our understanding of planetary formation, the distribution of life's ingredients, and our place in the galactic community. The rapid succession of interstellar discoveries, from Oumuamua to Borisov to 3Y Atlas, suggests that our solar system exists within a busy galactic highway where objects regularly travel between star systems. This realization transforms our perspective from viewing our solar system as an isolated island to understanding it as part of a vast, interconnected cosmic ecosystem. Future generations of astronomers will have access to increasingly sophisticated tools for detecting and studying these cosmic messengers. Each new discovery will add to our growing understanding of how matter, and potentially life itself, spreads throughout the galaxy. 3I Atlas may be just the beginning of a new chapter in human exploration of the cosmos, one where the universe comes to us in the form of ancient travelers from distant stars. The discovery of 3I Atlas opens an unprecedented window into the ancient cosmos, offering humanity its first detailed look at a massive object from another star system. As this colossal interstellar visitor races through our solar system, it carries secrets from a distant world that may have existed billions of years before Earth formed. The data collected during its brief passage will enhance our understanding of planetary formation, the distribution of life's building blocks, and our cosmic heritage. What other ancient messengers await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible cosmic discoveries. Until next time, keep looking up. What if the most terrifying message from the stars wasn't a broadcast but an object? And what if that object wasn't just visiting but reporting back to something else? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object designated 3I Atlas. But as they decoded its transmissions and analyzed its impossible flight path, they confirmed a fear that humanity has held for centuries. This wasn't a random rock, it was a messenger. Let's explore this together. The impossible visitor. So, what happens when a visitor from another star system doesn't just tumble through, but navigates? When the Vera C. Rubin Observatory in Chile first flagged 3I Atlas in early 2025, it immediately defied every known classification. Unlike our previous interstellar guests, this object exhibited something that sent a chill through every Mission Control Center-controlled flight patterns. Dr. Karen Meach, a University of Hawaii astronomer renowned for her work on Oumuamua, was among the first to note that its trajectory was non-ballistic to a degree that is simply not natural. It executed deliberate, impossibly precise course corrections. Its sheer scale was staggering. It was surrounded by a massive 700,000-kilometer coma, a glowing envelope of gas and plasma nearly half the diameter of our own sun. But unlike a comet's coma, this one didn't sublimate chaotically. It pulsed, beating like a cosmic heart with powerful electromagnetic signals at a frequency of 1.42 gigahertz. The hydrogen line, a frequency famous in SETI circles, firing in a perfect rhythm once every 147 seconds. As this impossible visitor carved its way through our asteroid belt with surgical precision, one chilling question began to emerge. What if this thing wasn't exploring, but was actively reporting back? When physics stopped making sense. Here's where the story takes a sharp turn from a scientific curiosity into a genuine threat. Most objects from beyond our solar system follow chaotic trajectories, their paths dictated by gravity. But 3I Atlas demonstrated something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lascar from the Paris Observatory ran the orbital simulations backward, they discovered something statistically impossible without intelligent intervention. The path of 3Y Atlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was simply breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arcseconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board, avoiding every conceivable threat with a precision that suggested either advanced, long-term planning or sophisticated real-time control. This wasn't a random space rock wandering through the cosmos, it was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. The unsettling feeling that we were dealing with something far beyond our comprehension only intensified when NASA, under the guidance of senior JWS scientists like Dr. Jane Rigby, pointed the James Webb Space Telescope toward 3I Atlas. The results that came back didn't just challenge our understanding, they completely rewrote the rulebook. The thermal readings showed a consistent, stable temperature of 120 Kelvin, with rhythmic heat emission patterns that pulsed in sync with its radio signals, a behavior that defies thermodynamics. Webb's spectrography revealed materials never before seen, including hyper-reflective compounds that returned almost 99% of the light that hit them. But the most disturbing discovery was a faint, recurring electromagnetic anomaly echoing from within. This low-bandwidth frequency at 408 MHz, repeated every 147 seconds, matching the exact signature of a known pulsar, PSRB 1919+21. The problem, as any physicist would attest, was that the object had no spinning core, and no magnetic field capable of generating such a signal. It appeared to be mimicking something it had encountered, or worse, actively communicating with something beyond our detection capabilities. 2 visitors, 1 terrifying pattern. The mystery deepened significantly when researchers cross-referenced 3I Atlas's electromagnetic signature with archived data from Oumuamua. The comparison revealed something that sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation, but active engagement. It was the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. Just when scientists believed they had mapped 3I Atlas's future trajectory, the object performed a maneuver that shattered every remaining assumption. Telescopes in Chile and Hawaii recorded a subtle but unmistakable course shift that couldn't be explained by gravity or solar wind. The object veered slightly off its projected arc, executing a 15-meter-per-second delta V that realigned its vector, bringing it 0.1 astronomical units closer to Earth's orbital plane. To mission analysts at NASA's Deep Space Network at JPL, the implications were alarming. The timing and precision of this maneuver implied conscious decision-making. The maneuver occurred precisely when the James Webb Space Telescope had achieved its optimal tracking position, suggesting the object was not only aware of our surveillance efforts, but was reacting to them. This transformed 3I Atlas from an astronomical curiosity into a potential confirmation of technologies far beyond our own. It was no longer a passive object of study, it was an active participant in a cosmic dialogue we didn't know we were having, a dialogue that was now escalating. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal, the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't arbitrary concepts, they represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. James Webb's detailed spectroscopic analysis revealed another disturbing layer to the 3I Atlas mystery. The telescope detected complex carbon molecules on the object's outer shell, specifically polycyclic aromatic hydrocarbons, which are the building blocks of prebiotic chemistry. These compounds, as astrobiologists like Carl Sagan have long theorized, are the precursors to life itself. What was alarming was the purity and organization of these molecules. Unlike the chaotic mixtures found in comets, the compounds on 3Y Atlas showed 99.9% isotopic consistency, a level of molecular organization that just doesn't occur naturally in space. The spectral lines at 3.3 micrometers, a key signature of PA8s, were honestly, unnaturally sharp and clear. Some researchers, including those at MIT under the guidance of experts like Dr. Sarah Seeger, began to theorize that 3Y Atlas might represent a seed ship, an ancient vessel designed not just to explore, but to plant the foundations of life on suitable worlds. If this theory held merit, then Earth's location along the object's trajectory might not be a coincidence at all. When Earth responded to the cosmic visitor, the connection between 3I Atlas and Earth became far more unsettling when a classified high-altitude surveillance balloon managed by the U.S. Antarctic program detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 gigahertz, sharp and centered precisely above the South Pole. Initially dismissed as interference, its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low-frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3I Atlas. The synchronization was impossible to dismiss as a coincidence. Somehow, this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The Asteroid Belt Death Run. 3I Atlas is currently navigating through the main asteroid belt, a phase that presents unprecedented risks. Unlike other objects, 3I Atlas cuts directly through the belt's core at a low 5-degree inclination, passing through a region with a particle density 50% higher than the belt's average. The object, moving at a blistering 42 kilometers per second, is surrounded by its massive 700,000-kilometer coma, creating unprecedented interactions with the billions of objects in the belt. Planetary scientists at institutions like the Southwest Research Institute are watching with bated breath. As 3I Atlas moves through this environment with its powerful electromagnetic signature, it's creating disturbances never before observed. While a direct collision remains statistically low, its gravitational and electromagnetic effects could potentially alter the trajectories of other bodies in unpredictable ways, creating a cascading effect or, more concerningly, redirecting the object itself toward Earth's orbital path. This is a cosmic gamble with planetary consequences. Rewiring our solar system's neural network. Scientists have now discovered that 3I Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic web effect. As 3I Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen Telescope Array show that 3Y Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, A signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings. But either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The story of 3I Atlas is far from over. In fact, it may just be the beginning of a much larger, more terrifying story. The mounting evidence, the deliberate course corrections, the mathematical signals, the organic chemistry, and now a broadcast pointed toward deep space, all suggest that this object is not the main event. It is a precursor. It is an announcement that our solar system is no longer a quiet, isolated neighborhood. We may have just accidentally triggered a sequence of events that will fundamentally change humanity's place in the universe, and we are completely unprepared for what comes next. Thank you for watching Future Facts. A Falcon 9 rocket just spotted something moving on the surface of an object from another star system. That was the claim that recently exploded online, suggesting SpaceX secretly sent a mission to an ancient interstellar comet. But what is the truth behind this cosmic visitor and the viral rumors? The reality is even more fascinating than the fiction, and it forces us to confront a critical question about humanity's future in space. Let's explore this together. What makes 3I Atlas special? So what's the big deal about this specific visitor? Imagine an object older than our own sun, which is about 4.6 billion years old, carrying secrets from a star system we've never seen. That's what we're talking about here. While the name 3I Atlas is fictional, it's clearly inspired by real objects like Comet C 2023 A3 Tsuchinshan Atlas. This comet is a long-period visitor from the Oort cloud, a theorized sphere of icy bodies over 150 trillion kilometers away. True interstellar visitors, like the ones discovered by astronomers Robert Warwick and Gennady Borisov, come from even farther. Warwick's discovery, Oumuamua, was a 400-meter-long enigma traveling at a blistering 87.3 kilometers per second relative to the Sun. Borisov's comet was moving at a more sedate but still incredible 32 kilometers per second. These objects are time capsules containing the original chemical ingredients from another star's formation. Scientists believe analyzing even a gram of material from one of these could reveal isotopic ratios and molecular structures that don't exist in our solar system. It's like receiving a message in a bottle from across a cosmic ocean. This isn't just another rock, it's a pristine sample of galactic history delivered right to our doorstep. The Falcon 9 connection debunked. Let's get straight to it. Did a Falcon 9 rocket actually intercept anything on a comet? The short answer is no. The viral claim suggested a secret SpaceX mission, but the reality is much more routine. Public launch records show that Falcon 9 rockets are constantly lifting off, with SpaceX having completed over 100 launches in 2023 alone. Their missions are focused on deploying batches of 22 to 23 Starlink satellites into low Earth orbit, typically at an altitude of about 550 kilometers, or launching sensitive payloads for the National Reconnaissance Office. A Falcon 9's job is to provide the initial boost into a specific orbital slot around Earth. It is not a deep space interceptor. The idea of a Falcon 9 spontaneously chasing down an interstellar object moving at over 100,000 kilometers per hour is pure science fiction. The rocket that places satellites in orbit simply doesn't have the fuel, the engines, or the trajectory to perform such a maneuver. It's like using a city bus to try and compete in a Formula One race. The bus is great at its job, but it's the wrong tool for that particular track. The viral story was compelling, but it fundamentally misunderstands what these remarkable rockets are built to do. The physics of interception. Why couldn't a Falcon 9 just go and chase a comet? The numbers are staggering, and it all comes down to a concept called delta V, the currency of space travel. To get a payload to low Earth orbit, a Falcon 9 provides about 9.4 kilometers per second of delta V. To catch Oumuamua, studies from the Initiative for Interstellar Studies under a concept called Project Lyra estimated a required delta V of over 30 kilometers per second, maybe even up to 70 kilometers per second, depending on the launch window. That's an order of magnitude more energy. Our fastest spacecraft, the Parker Solar Probe, will reach a mind-bending 192 kilometers per second, but only after 7 gravity assists from Venus over 7 years, using the Sun's own immense gravity as a slingshot. It needed a massive Delta IV heavy rocket just to get started. A standard Falcon 9 is a workhorse. but it's not built for that kind of high-energy, deep space chase. It would be like trying to jump onto a bullet train as it speeds through your station. You can't just run and catch it. You need a vehicle that can match its speed and trajectory perfectly, and that requires an astronomical amount of energy planned far in advance. Alien chemistry possibilities. Here's where things get really fascinating. What if these interstellar visitors are carrying chemical recipes we've never seen before? An object formed in a completely different stellar environment would be built from a different cloud of gas and dust. Telescopic analysis of 2I Borisov, led by scientists like Dennis Bodowitz, revealed it contained anywhere from 9 to 26 times more carbon monoxide than the average solar system comet. This suggests it formed in an extremely cold, carbon-rich region around its home star. This raises a profound question, one often explored by thinkers like Harvard astronomer Avi Loeb. Could these objects carry complex organic molecules with structures fundamentally different from those on Earth? Life here is based on left-handed amino acids. Finding right-handed versions on an interstellar object would be revolutionary. It would be powerful evidence for the theory of panspermia, the idea that the chemical seeds of life are spread throughout the galaxy on objects just like these. If we could analyze a sample, we might find that the building blocks of life are common across the cosmos, but maybe they follow slightly different rules. It would be the ultimate test of whether life as we know it is a cosmic fluke or a universal blueprint. 3 missed opportunities. The frustration for scientists is that we've seen these messengers fly by, but we've been unable to do anything but watch. We are 3 for 3 on missed chances. First, there was one I Oumuamua, discovered on October 19, 2017, by Robert Warwick. By the time astronomers realized how strange it was already rocketing out of our solar system, far too fast to be caught. Its bizarre 400-meter-long cigar-like shape and its mysterious acceleration still spark debate. Then, on August 30, 2019, amateur astronomer Gennady Borisov spotted 2I Borisov. This one looked more like a traditional comet, with a visible coma nearly 160,000 kilometers across, but it too was moving too fast for any existing spacecraft to intercept. The window of opportunity to launch a mission was just a few months, far too short to build and prepare a spacecraft from scratch. Each of these objects represented a unique, fleeting opportunity to study matter from another star system up close. Instead, we were left observing from millions of miles away. It's like having priceless ancient artifacts float past your window, just out of reach. Future intercept technology. So, are we doomed to just watch these cosmic treasures fly by forever? Not necessarily. The European Space Agency, or ESA, is already building a solution. It's called the Comet Interceptor mission, planned for launch in 2029 aboard an Ariane 6 rocket. This is a game changer. The spacecraft won't have a specific target when it launches. Instead, it will travel to the Sun-Earth L2 point, a stable gravitational parking spot about 1.5 million kilometers from Earth, and it will wait. It will hibernate there for up to 3 years, acting as a rapid response system. When astronomers, perhaps using the upcoming Vera C. Rubin Observatory, discover a new long-period comet, or ideally, a new interstellar object with a reachable trajectory, Comet Interceptor will be ready to go. Once it gets its target, the main spacecraft will release 2 smaller probes. Together, the 3 vehicles will fly through the comet's coma from different angles, creating a 3-dimensional profile of a pristine object. This 3-for-1 approach will give us unprecedented data on the object's nucleus, its gas, its dust, and the surrounding plasma environment. This mission is our first real shot at studying one of these messengers up close. Scientific implications. Let's talk about the bottom line. What's at stake here? The discoveries from intercepting an interstellar object could be transformative, honestly rewriting textbooks on multiple fronts. We're not just talking about seeing another space rock. We're talking about answering some of the deepest questions in science. First, its chemical composition could provide a direct sample of the materials that form planets in other star systems. We could learn if the building blocks of rocky planets and gas giants are the same across the galaxy. Second, studying its isotopic ratios, the specific blend of neutrons in its atoms, could give us a definitive fingerprint of its origin, proving beyond any doubt it came from another star. And perhaps most importantly, as scientists like Avi Loeb argue, we should be open to all possibilities, including looking for chemical signatures of technology. Confirming unique organic molecules would provide powerful evidence for panspermia, suggesting the ingredients for life are widespread throughout the universe. This is about understanding our own origins, the prevalence of life's ingredients, and our ultimate place in the cosmos. It's a chance to move from speculation to direct evidence. Trajectory analysis and mysteries. So how do we even know these objects are from another star system? Well, the answer actually lies in the mathematics of their journey. Objects in our solar system orbit the sun in closed ellipses, but interstellar visitors travel on a hyperbolic trajectory, a one-way trip really. Their sheer speed is the giveaway. But you know, the path itself can hold deeper secrets. For example, a team led by Marco Micheli of the European Space Agency confirmed that Oumuamua had a slight non-gravitational acceleration. It was a tiny but persistent push of about 1.5 millimeters per second squared. The leading scientific theory is that this was caused by the outgassing of hydrogen ice, creating an invisible jet effect. However, the lack of a visible coma to confirm this keeps the mystery alive and, honestly, fuels speculation. This riddle just highlights how much we have to learn. Analyzing the precise path of future visitors could tell us if they are solid, inert bodies or if they're actively shedding material in ways we can't easily detect from Earth, which really challenges our models of what a comet even is. The official facts. So, let's set the record straight, separating the viral fiction from the scientific facts. The object that fueled recent excitement is likely based on Comet C 2023 A3 Tsuchinshan Atlas. It was first spotted on January 9, 2023, and confirmed on February 22, 2023. ATLAS itself stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot near-Earth objects. This comet is not interstellar, it's a long-period comet from the Oort cloud. Its orbit is incredibly long, taking tens of thousands of years. It made its closest approach to the Sun, its perihelion, on September 27, 2024, at a distance of about 58 million kilometers. Its closest approach to Earth was on October 12, 2024, at a safe distance of about 71 million kilometers. Its nucleus is estimated to be several kilometers in diameter, and to be perfectly clear, no spacecraft from SpaceX or any other agency has intercepted this comet. The Falcon 9 launches are real, but they are completely unrelated. The bigger picture. The Falcon 9 story, while inaccurate, highlights a much deeper truth. Humanity is now at a crossroads. For the first time, we have the technology to not just observe these messengers, but to potentially reach out and touch them. The detection of multiple interstellar visitors in just a few years suggests these encounters are actually pretty common. And with new tools like the Vera C. Rubin Observatory coming online, its director, Zeljko Ivezic, predicts we might soon be spotting dozens of these objects every year. We are no longer just passive observers on the shore of the cosmic ocean. We are building the ships to sail it. The development of missions like ESA's Comet Interceptor is the first step toward a proactive strategy. The real question is no longer can we do it, but will we commit? Some scientists are now pushing for a permanent, ready-to-launch intercept program. It's a question of priorities. The choice we make now will define the next great era of space exploration and could determine if our generation is the one that finally answers the question of what lies beyond our cosmic neighborhood. So, Falcon 9 didn't literally chase a comet, but the conversation it started is critical. We are on the verge of being able to sample another star system. The next visitor is coming, and the one after that. The only question is whether we'll be ready to answer the door when it knocks. What do you think? Should we be building a permanent intercept mission, ready to launch at a moment's notice? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next exploration into the mysteries of the cosmos. Thanks for watching Future Facts. Right now, a 1970s spacecraft traveling at 38,000 miles per hour through the void between stars has detected something that's rewriting our understanding of the cosmos. Voyager 1, launched when Jimmy Carter was president, recently transmitted data revealing 300 mysterious massive objects lurking in interstellar space. Objects that shouldn't exist according to our current theories. After surviving computer failures, memory corruption, and radiation levels that would kill a human instantly, this car-sized probe continues making discoveries that challenge everything we thought we knew about the universe beyond our solar system. The impossible mission that refused to die. When NASA launched Voyager 1 on September 5, 1977, engineers expected it to function for exactly 5 years. The spacecraft was designed to study Jupiter and Saturn, then quietly drift into the cosmic void as a technological relic. Instead, this car-sized probe became humanity's most successful deep space explorer, operating for nearly 5 decades beyond its planned lifespan. The mission's longevity stems from brilliant engineering and fortunate timing. Voyager 1 exploited a rare planetary alignment that occurs once every 175 years, using gravitational assists from Jupiter and Saturn to accelerate toward the outer solar system. This grand tour trajectory, conceived by mathematician Michael Minovich, transformed what should have been a routine flyby mission into an epic journey to the stars. Today, Voyager 1 operates with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo. Its instruments run on power generated by decaying plutonium, producing less electricity each year as the radioactive fuel ages. Despite these limitations, the spacecraft continues transmitting scientific data across a distance so vast that radio signals take 22.5 hours to reach Earth. The probe's survival represents one of engineering's greatest triumphs, proving that well-designed systems can exceed their creators' wildest expectations when pushed beyond all reasonable limits. Breaking through the solar system's final barrier. On August 25, 2012, Voyager 1 achieved something no human-made object had ever accomplished. It crossed the heliopause and entered interstellar space. This boundary, located 121 astronomical units from the Sun, marks where our star's influence ends and the true void between stars begins. The crossing wasn't a simple transition, but a complex journey through what scientists call the twilight zone. Voyager 1 spent months navigating this region, where solar wind particles clash with the interstellar medium in a cosmic battle that creates unexpected phenomena. The spacecraft detected dramatic increases in galactic cosmic rays, mysterious particles from distant stellar explosions, while simultaneously observing sharp decreases in solar particles. What made this discovery revolutionary was its timing and precision. Scientists had theorized about the heliopause for decades, but Voyager 1 provided the first direct measurements of this cosmic boundary. The probe's instruments revealed that interstellar space contains particle densities 100 times higher than the protected region within our solar system. The heliopause itself proved more complex than predicted. Rather than a sharp boundary, Voyager 1 encountered a thick, dynamic region where magnetic fields twisted and particle densities fluctuated wildly. This discovery forced scientists to completely revise their understanding of how our solar system interacts with the galaxy beyond. The mysterious hum of deep space. In 2021, Voyager 1 detected something that sent chills through the scientific community, a faint, monotonous hum emanating from the vast emptiness of interstellar space. This wasn't random noise but a persistent vibration from plasma waves in the interstellar medium, revealing that the space between stars isn't truly empty. The discovery came from Voyager 1's plasma wave system, which had been monitoring larger eruptions from the Sun that affect interstellar gas. When these solar outbursts quieted, scientists noticed a background hum that had been masked by the more dramatic events. Cornell University's Stella Koch-Acker, who led the research, described it as very faint and monotone because it is in a narrow frequency bandwidth. This cosmic hum provides unprecedented insights into the structure of interstellar space. Unlike the chaotic environment within our solar system, the interstellar medium maintains a steady, predictable rhythm that Voyager 1 can monitor continuously. The probe essentially acts as a cosmic weather station, reporting conditions in a region no spacecraft had ever explored. The hum's consistency allows scientists to track how interstellar plasma is distributed throughout the galaxy. Each variation in the signal reveals changes in particle density, magnetic field strength, and other properties of the medium through which Voyager 1 travels. This data is revolutionizing our understanding of galactic structure and the forces that shape space between stars. Computer failures and miraculous recoveries. Voyager 1's journey hasn't been without terrifying moments that nearly ended the mission forever. In November 2023, the spacecraft suddenly stopped sending coherent data, instead transmitting meaningless streams of binary code that completely baffled NASA engineers. The problem actually originated in the flight data system, where a corrupted memory chip prevented normal operations. Now, this failure was particularly alarming because it affected the spacecraft's ability to communicate with Earth. While Voyager 1's radio signal remained strong, indicating the antenna was properly aligned, the data it transmitted was just complete gibberish. Engineers faced the nightmare scenario of losing contact with humanity's most distant explorer, just as it was making groundbreaking discoveries in interstellar space. The solution, though, required extraordinary ingenuity. NASA engineers spent months analyzing the corrupted memory, eventually determining that about 3% of the flight data system's memory had been damaged. They developed a workaround that relocated essential code to undamaged memory sections, essentially performing remote surgery on a computer 15 billion miles away. The repair process was agonizingly slow. Each command took 22.5 hours to reach Voyager 1, and responses took another 22.5 hours to return to Earth. The heliopause's shocking behavior. Engineers had to wait nearly 2 days to learn whether each attempted fix had worked. The successful restoration of communications in April 2024 represented one of the most challenging remote repairs in space exploration history. Recent observations from Voyager 1 have revealed that the heliopause, the boundary of our solar system, behaves in ways that really contradict decades of scientific theory. Rather than maintaining a stable position, this cosmic border moves, shifts, and creates irregular angles that leave researchers struggling to explain what they're observing. The heliopause's instability became apparent when comparing data from Voyager 1 and Voyager 2. Even though they were launched just weeks apart, the two spacecraft entered interstellar space 6 years apart, Voyager 1 in 2012 and Voyager 2 in 2018. This timing difference suggests the boundary itself moved significantly during that period. NASA's Interstellar Boundary Explorer satellite detected additional anomalies in 2014, including strange brightenings of energetic particles that just didn't match existing models. These observations suggest the heliopause experiences dramatic fluctuations driven by forces scientists are only beginning to understand. The boundary's complexity extends well beyond simple movement. Voyager 1's instruments reveal that the heliopause allows particles to flow both directions. Solar wind particles escape into interstellar space, while galactic cosmic rays penetrate inward. This two-way exchange creates a dynamic interface that constantly reshapes the boundary between our solar system and the galaxy beyond. These discoveries have profound implications for understanding how stellar systems interact with their galactic environment and how cosmic radiation affects planetary atmospheres throughout the universe. Cosmic rays and the radiation reality. Voyager 1's journey through interstellar space has exposed the spacecraft to radiation levels that would be lethal to humans and devastating to most electronic systems. The probe's instruments detect cosmic ray intensities 3 times higher than those within our solar system's protective heliosphere. These cosmic rays aren't ordinary radiation but high-energy particles accelerated by distant supernovae and other violent cosmic events. They travel at nearly the speed of light and can penetrate solid matter, causing cumulative damage to electronic components over time. Voyager 1's continued operation in this harsh environment demonstrates the remarkable resilience of 1970s engineering. The spacecraft's cosmic ray subsystem has documented how these particles vary as Voyager 1 moves through different regions of interstellar space. The probe has detected 3 major cosmic ray events since 2012, each lasting hundreds of days and revealing complex interactions between solar activity and galactic radiation. These measurements provide crucial data for future interstellar missions. Understanding cosmic ray patterns helps engineers design shielding systems for spacecraft and habitats that might one day venture beyond our solar system. Voyager 1's radiation exposure data serves as a real-world test of how technology performs in the galaxy's most extreme environments. The probe's survival also reveals unexpected properties of interstellar space itself. Certain regions appear to provide natural shielding from cosmic rays, while others concentrate these deadly particles into focused beams that could threaten future explorers. The 300 mysterious objects discovery. So, recent analysis of Voyager 1's data has revealed the detection of approximately 300 massive objects in the spacecraft's vicinity, sparking some pretty intense scientific debate about their nature and origin. These objects, identified through subtle gravitational effects and particle interactions, actually represent one of the most intriguing discoveries in the probe's 47-year journey. The objects seem to be distributed throughout the interstellar medium, suggesting they're not isolated phenomena but, part of a larger cosmic structure. Their masses range from asteroid-sized bodies to objects comparable to small moons, yet they emit no detectable light or radio signals. This invisibility makes them incredibly difficult to study using traditional astronomical methods. Scientists have proposed several explanations for these mysterious objects. They could be dark matter clumps, primordial black holes, or previously unknown types of interstellar debris. Another possibility is that they represent a new class of cosmic object that forms in the unique conditions of interstellar space. The discovery really challenges our understanding of what exists in the supposed emptiness between stars. If these objects are common throughout the galaxy, they could represent a significant fraction of the universe's missing mass. Their gravitational effects might influence star formation, galactic structure, and the evolution of planetary systems. Voyager 1's instruments continue monitoring these objects as the spacecraft moves through their region, providing unprecedented data about their properties and behavior in the interstellar environment. Technology surviving the impossible. Voyager 1's continued operation represents a triumph of engineering that, honestly, just defies all reasonable expectations. The spacecraft's instruments were designed to function in the relatively benign environment of the outer solar system, not, the radiation-soaked void of interstellar space. Yet they continue operating at temperatures that would freeze most modern electronics solid. The probe's power system, which is based on radioisotope thermoelectric generators, produces less electricity each year as its plutonium fuel decays. NASA engineers have been forced to shut down non-essential systems one by one, prioritizing the most scientifically valuable instruments. Heaters that once kept components warm have been turned off, yet the instruments continue functioning despite experiencing temperatures hundreds of degrees below freezing. This survival really stems from the robust design philosophy of 1970s aerospace engineering. Components were built with massive safety margins and redundant systems that, honestly, modern cost-cutting measures often eliminate. The spacecraft's analog systems prove more resilient to radiation damage than the digital electronics that dominate contemporary spacecraft. NASA's ability to maintain Voyager 1 across such vast distances showcases the evolution of deep space communication. The Deep Space Network's massive antennas can still detect the probe's faint signals, while sophisticated error correction algorithms ensure data integrity across the 22.5-hour communication delay. The mission's longevity provides invaluable lessons for designing future interstellar probes that must operate independently for decades or even centuries while traveling to nearby star systems. The heliosphere's protective shield. Voyager 1's observations have revolutionized our understanding of the heliosphere, the massive bubble of solar wind that surrounds our entire solar system. This protective shield, stretching 11 billion miles from the Sun, acts as cosmic armor that deflects most galactic radiation from reaching Earth and other planets. The heliosphere's structure proves far more complex than scientists initially believed. Rather than a simple spherical bubble, Voyager 1's data reveals a dynamic, ever-changing boundary that responds to solar activity, galactic magnetic fields, and the solar system's motion through space. The Sun's 450,000-mile-per-hour journey around the galaxy creates a bow shock where the heliosphere plows through the interstellar medium. This cosmic shield's importance really cannot be overstated. Without the heliosphere's protection, Earth would be bombarded by lethal cosmic radiation that could strip away our atmosphere and sterilize the planet's surface. The shield's effectiveness varies with solar activity. During solar maximum, increased solar wind strengthens the barrier, while solar minimum periods allow more galactic radiation to penetrate. Voyager 1's measurements show that the heliosphere's shape changes constantly as it encounters different regions of interstellar space. Dense molecular clouds can compress the boundary, while sparse regions allow it to expand. These variations affect the radiation environment throughout the solar system, potentially influencing climate patterns and biological evolution on Earth. Understanding the heliosphere's behavior helps scientists predict how our solar system will fare as it moves through different galactic environments over millions of years. Legacy of the Ultimate Explorer. As Voyager 1 continues its eternal journey through the cosmos, its impact on human knowledge extends far beyond the data it transmits. The mission has fundamentally changed our perspective on our place in the universe, revealing both the vastness of space and the remarkable resilience of human ingenuity. The spacecraft carries the famous Golden Record, a collection of sounds, images, and messages from Earth intended for any extraterrestrial intelligence that might encounter it. While the chances of alien discovery remain infinitesimally small, the record represents humanity's first attempt at interstellar communication and, really, our hope for cosmic recognition. Voyager 1's discoveries have inspired numerous follow-up missions. The Galileo and Juno missions to Jupiter, the Cassini mission to Saturn, and planned missions to Uranus and Neptune all trace their origins to Voyager's initial reconnaissance. The probe's identification of potentially habitable moons like Europa and Enceladus has redirected the search for extraterrestrial life toward these icy worlds. The mission's longevity demonstrates that well-designed systems can operate far beyond their intended lifespans when supported by dedicated teams of engineers and scientists. NASA expects Voyager 1 to continue transmitting data until at least 2025, with some instruments potentially operating until 2030. Even after its instruments fall silent, Voyager 1 will continue traveling through the galaxy for millions of years, carrying its golden record as a testament to human curiosity and our desire to explore the unknown. The probe represents humanity's first step toward becoming a truly interstellar species. Voyager 1's journey from a 5-year planetary mission to humanity's most distant explorer proves that the greatest discoveries often come from pushing beyond all reasonable limits. This remarkable spacecraft has revealed the true nature of interstellar space, detected mysterious objects in the cosmic void, and demonstrated that human ingenuity can overcome seemingly impossible challenges. As Voyager 1 continues its eternal voyage through the stars, it carries with it our hopes, dreams, and unquenchable curiosity about the universe. What other secrets await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible space exploration stories. Until next time, keep looking up.